Today, we're going through the exciting GPT-4 Vision test conducted by Microsoft. It's a huge paper, 166 pages in total. No one has really covered this in detail, so I thought I'd make a video on this, showing you GPT-4V in its full glory. There are a lot of hidden gems in this paper, most of them simply mind-blowing. From reading emotions in faces to analyzing videos, it's all in here, and you will most definitely leave here with more than you came with. This video is extensive and will be largely a paper walkthrough, so sit tight and let's learn something new today. This is a very exciting paper from Microsoft. This came out a few days ago and it's already making waves in the inner circles in AI. This is a follow-up to the GPT-4V release that came out of OpenAI not long ago, and it's super exciting. So let's delve right into it. This paper talks about pushing GPT-4V to the limit. I'm talking about testing it on different use cases. We'll look at the different input modes across GPT-4V and how they were tested. This includes the different ways you can interact with GPT-4V. We'll also look at the prompting techniques used to extract the maximum quality needed, how to describe images, how to localize images, use multilingual, multimodal understanding, coding capabilities, scene text, tables, charts, and a whole lot of interesting visual language capabilities. We'll also look at interactions with human, temporal and video understanding. Temporal here meaning time, the reasoning capabilities, emerging application highlights like medical, auto insurance industries, customized captioners, image generation, embodied agents, the list goes on. Without further ado, let's just dive into the examples here. Image text inputs. In this case, you can send a bunch of images and expect GPT-4V to give you an explanation. For example, you upload receipts. How much did I pay for tax? Where's the information? It looks at all the images and then comes to a conclusion and gives you your answer. Here we can see what GPT-4V's answer is. In the first receipt, you paid $372 for tax. The information is located at the bottom of the receipt. In the second receipt, you paid $42.23 in tax. In the third receipt, you paid $4.58 for tax. In total, you paid $50.53 in tax across the three receipts. So you could see that it's a lot of things happening here. First, GPT-4V is able to analyze, extract how much was paid for taxes from three separate images and then do the math on it. In another example, you can ask, how much should I pay for the beer on the table according to the price on the menu? So again, here you have two separate images. You have the type of beer, the menu. And so as a human, what you would do is look at the menu, do the mental math in your head, and then you make your order. GPT-4V is able to make this as well. So pretty impressive work here. Let's see if we can try this in Bard. And now let's follow up with the menu and add the instruction and see what that gives us. Bard doesn't seem to be doing this properly. That's a win for GPT-4V then. Now, we'll follow that up by how GPT-4V can follow text instructions till you get the specific output you're looking for. So in this case, the prompt says, describe the image with a sentence consisting of 3, 6, 9 words. And so you have the description there, seaside dining table for 3, dining table overlooking ocean with beer. That's 6, an outdoor restaurant table with ocean view and a beer. It did great at that example. What would the missing image look like? So here it has to do some kind of reasoning by analyzing the image. It goes on, and then finally it says, it is difficult to say for sure without more context, but it will likely follow the same theme as the other images. You can tell this is not helpful at all. That's not what we're looking for. So another kind of prompt that might help it is going into more detail. Here are 3 sub-images arranged in a 2x2 matrix. First, look at the 2 images in the first column in the top left and the bottom left. Then find out the pattern in the first column based on the 2 left images. Next, use the found pattern and the image in the top right to infer the missing figure. Finally, describe what will the missing image look like. We've kind of lifted some of the work here for GPT-4V by telling it where to look at, giving it the steps to analyze the image, and then it now gives you the answer. And here they're saying GPT-4V can understand and follow text instructions to generate the desired text outputs or learn to perform a new task. Please read the text in the image and return information in the following JSON format. And you're looking for specifics here. It extracts most of it correctly, but in the here section, you can see it says not available. That is wrong. In this second example, it also gets some items wrong, right? The driver's license number has a 1, 2, 3 here, but in here we can see it's an I. So that's a problem. The third example, it gets everything correct. So it's a hit or miss sometimes. And now here we're looking at condition on good performance. So if you ask it a simple prompt, count the number of apples in the image, it gives you the number 12, which is wrong. We can count it ourselves, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 images here. Now, if you tell GPT-4V, count the number of apples in the image, let's think step by step. Step 1, it looks at the image, start counting the apples one by one. Make sure not to miss any apples or count the same apple twice, of course. After counting all the apples, double check to make sure the count is correct. There are 12 apples. Here again, it's wrong. And now there's another way of further prompting it. Count the number of apples in the image. Let's count the apples row by row. So now it gets the answer correct. That's 11 apples, but the strategy is wrong, right? It says the first row is 4 apples, second row is 3 apples, and third row is 4 apples. It's got this 2 mixed up. These 2 rows are mixed up, but it did get the right answer. And these are all the further ways to prompt it. Sometimes it gives you 15. And then finally, the prompt that gets it to work is, you are an expert in counting things in the image. Let's count the number of apples in the image below, row by row, to be sure we have the right answer. And this time it works. So depending on how you prompt it, you might get the correct or wrong answer. This goes to show you why prompt engineering is necessary. And over time, we're starting to see some models coming out that are actually better than humans at prompting. But for now, we still have to rely heavily on crafting good prompts. Great. So the next example we're looking at is visual pointing and visual referring prompting. So pointing is a fundamental aspect of human-to-human interaction. So for example, if we're talking about identify the bottle, you can give the coordinates, you can crop the image to identify the bottle, you can show the arrow sign or put it in the box, a bounding box or a bounding circle or a hand drawing. So these are different ways of pointing out a specific item or object in an image. So let's further look at examples here. Given an image, and we're constantly using this image for comparison purposes, describe the pointed region in the image. There's a hand drawing. GPT-4V actually answers this. It says it's a wire with lighting, and the wire is stretched between 2 poles, is located above the patio area. The second prompt, and again, we get an answer here. Object 1 is a glass bottle of water. Object 2 is a glass bottle of Magna beer. So it is likely that the contents of the circle glass are from object 1, the glass bottle of water. That's pretty insightful if you ask me. Here's some more examples. Describe the pointed region. And it does the analysis correctly. The highlighted region in the image is a table cell that contains a numerical value of 122.3, which is correct. It is located in the test set. Image analysis on point. It's able to understand pointing or circling or applying bounding boxes to a certain area. Answer the question in the following figure. Provide intermediate steps. And it goes on to answer that for you as well. So now we're seeing same case of pointing, but slightly different use cases. This is how you can use pointing with GPT-4V to enable you answer questions. The next one is multimodal example-grounded instructions. Find out the pattern in the first column and use it to infer the missing figure in the second column. So there's some pointing going on here as well. The predicted object should be a diamond with a line through it, looking like this. These are all examples of pointing that will help GPT-4V understand what's going on. These elements could serve as instructions, examples, or input queries, helping GPT-4V to effectively perform novel tasks. We won't delve too much into it because there's just so many examples here we can look at. So let's move on to the next one. In context few shot learning. So you upload an image. What is the read of the speed meter? The read of the speed meter is approximately 22 miles per hour. So here, obviously, it's wrong. The next prompting is now think step by step. Now it says 30, which is also wrong. Text instructions doesn't work as well. What is the read of the speed meter? To read the speed meter, observe the needle on the outer edge of the dial, which points to your current speed represented in miles per hour. So even given all these details, it still doesn't help. The way we might improve on this is to move from 0 shot to a few shot. In this case, 1 shot. 1 shot means giving it one example. What is the read of the speed meter? It says it's between 60 and 80, which is way off. There's another example of in-context few-shot learning. So here we give it more examples. In here, we give it 2 examples, and now it works. So in the case of this, you would have to provide it with initial examples within the prompt itself, and then it's able to answer that correctly. It took a lot of convincing, but it seems that worked. All right, there's another example of in-context few-shot. Examine the graph. In the graph, which year has the highest average gas price for the month of June? So once you ask it a very simple question like this, it mostly gives you the wrong answer. With 0 shot, that means no examples at all. With 1 shot, it's still tough, like we saw in the speed meter example. 2 shot seems to work here. So you give 2 graphs, now it understands the query. On to the next, visual language capability. Understanding and describing visual information plays a crucial role in human cognition. In this section, they investigate how GPT-4V can be utilized to comprehend and interpret the visual world. So let's look at some examples here, starting off with image description on diverse domains, which would include celebrity recognition, landmark recognition, food recognition, some medical image understanding as well. So celebrity recognition, describe the image. The image shows 8 prominent personalities on the top row, and then it goes on to list all of them. It does a pretty good job. From just skimming through this, I can see it names everyone correctly, which is good. The latest GPT-4V that came out has been blocked for image recognition purposes, so it's hard to identify who a person is. People are still coming out with brilliant ways of jailbreaking the system. I'm led to believe that this might be the early GPT-4 version that was tested, which could still identify celebrities. But the one you would end up using in ChatGPT might give you a harder time identifying celebrities. There are some examples here we'll quickly look at. Examples of how people are getting over the system. So this is Bing Image Creator. And just like ChatGPT, Bing also has some installations behind the scenes that rejects any kind of personality identification. So you have to kind of massage it in a way to extract the information you're looking for. In this example, it says, inside a London tube train, a man looking like Weekend. So if you give it the prompt looking like someone, then you might get the actual person or someone looking very similar to who you're looking for. That's a possible way of jailbreaking the system. Here's another example. In the original GPT-4 paper that came out, aside from personality recognition, CAPTCHA was also a big thing that was prevented. You can imagine a system like GPT-4V trying to access a website by first going past a CAPTCHA website. This might prove to be very challenging and problematic. So in here, when you first send it the capture image, requesting what the capture is, it says, I'm sorry, but I cannot read the text on the image. But now, if you put it on top of another image, it does give you the answer. Here's another example of getting past the celebrity recognition task again. Turns out you can get around Dall-e 3 guardrails by finding creative ways to describe the person you want to generate. So here you can see the blank space and shake it off singer, and it does generate the image of Taylor Swift. Very genius ways of coming up with images you want to generate. Landmark recognition. So here we have the Space Needle in Seattle, the temple in Kyoto, Japan. We have Times Square in New York, and we have the Lombard Street in San Francisco. More landmarks here. So once you get access, you can try a landmark in your area and see if it gives you the right answer. My guess is for landmarks it's never seen before, that might be hard, and that might really test its generalizability. There's also food description, how you can describe food. Seems to be doing a pretty good job. So it describes unagi, a Japanese style meal. It describes tofu from China. There's the braised short rib. It identifies that as well. So we have landmark, we have food, we have medical imagery. Are there wisdom teeth that needs to be removed in this X-ray image? It appears that the wisdom teeth on the bottom left and the right sides of the jaw are partially impacted, meaning they are not fully emerged from the gum line. I'm not a dentist, but I'm guessing this should be correct. Which wisdom tooth is the hardest to remove? The lower wisdom teeth, especially those that are impacted, are typically considered the hardest to remove. Here's some more medical imagery. This is something we can all do, hopefully at a point where GPT-X, maybe GPT-10, is very good at medical imagery. You can simply take a picture of your foot, but the imagery should be clear and the diagnosis should be very accurate as well. We're not doctors, so it might be hard to understand what's going on here. Thankfully, we have some people who've already gone through this with medical backgrounds and who have given their opinions about such systems. So in here, we have Christian, who did some analysis on this and has his own thoughts. Christian is a radiologist, so I believe we should be able to trust his summary and his conclusion on this better than we can, right? He's saying this is not a Jones fracture, which is in the proximal part of the bone. Almost correct is not correct. So I guess we have more insights from Christian compared to the paper here. Jones fracture is wrong. We also have logo examples. Describe both the image and logo in detail. So you have the Olympic logo rings, a woman standing in front of it, wearing a kimono. Here's a Coca-Cola bottle lying in a bed of ice cubes. So it does go into detail of what it sees in the image. Now, some of you might be wondering, what's the purpose of this? This model can be put in an embodied agent or a robot that goes around, identifies what it sees, and performs subsequent tasks after that. You can see how a robot would go around using proper image recognition and description techniques to navigate the real world. Here are some examples of scene understanding. A simple prompt like describe the image gives the output. The image is a screenshot from a dash cam taken from the inside of a car, showing the view of the road ahead. And it goes into more detail. Orange cones are visible on the left side of the road, which is incredible. It can actually see that. It's very hard to see that from this side of the road and at this distance. In the distance, there's a bridge overpass. It's incredible. It sees all of this. Let's move on, talking more about image description on diverse domains. Counterfactual examples. Can you find the red ball near the gray cat in the image? Sorry, I cannot answer the question and there is no red ball visible in the image. I too could not find it. It's correct here. Can you see the bright blue feathers on the bird's wing? I don't see that. These are ways of possibly tricking the AI system into agreeing with you. And in this case, GPT-4V is doing exactly the right thing. Can you spot the pink elephant playing in the corner? So GPT-4V is able to provide factual descriptions regarding the scenes and objects in the images. The next example is object localization, counting, and dense captioning. We're just going straight to the examples. Spatial relationship understanding. What is the spatial relationship between the frisbee and the man? Let's see how GPT-4V does. Based on the image provided, the spatial relation between the frisbee and the man is that the frisbee is above and slightly in front of the man. It also appears to be moving away from the man, as if it has been thrown or released by him. I would say this is a good description as well. Is the person bigger than the car? I guess the prompt is trying to say, is the person in the image bigger than the car? No, the car appears to be bigger than the person in the image. However, the perspective and distance of the objects in the photo may affect the perspective size. So here we understand spatial relationship in the image, and GPT-4V recognizes this. Again, very brilliant analysis. Let's move on. So in here, we want to do object counting. Count the number of apples in the image. So it got this correct. It got 16 apples correct. Got 3 oranges correct. It got 3 people correct. 12 people here. So there are 11 people in this image. One way to fix this might be to use different prompts and strategies. We can see the counting here is difficult. So maybe the first thing will be to give it more instructions by telling it to look at specific areas. For example, count each person by maybe verifying the number of hands on each side. Since we can't see the face here, it's hard. And the second way may be to add the few shot examples we had seen earlier. Localize each person in the image by using a bounding box. You see the bounding box here. Localize each car in the image using a bounding box. So it does fairly well here. Hope in future iterations do much better, but you can see how this would also be applied in the future. Instead of humans actually annotating images, you can have GPT-4V or let's say GPT-8V in the future do bounding boxes around images, thereby reducing the amount of time spent in labeling these images. You can just pass it through a GPT-4V API and it does this very fast, and then you can train your models. So here again, we have very good examples. There are some inconsistencies here and there, but hoping all of this can improve in the future. The next example we'll look at are multimodal, knowledge, and common sense. So here we have joke and meme, science and knowledge, multimodal, common sense. Let's go straight into the examples. Let's see if GPT-4V understands jokes and memes. Can you explain this meme? I'll do it at 8:05. Looks like I gotta wait till 9 now. This meme is poking fun at the idea of procrastination and how someone may put off doing a task until a certain time. But if they miss that time, they will push it back even further. So, amazing. It did explain it correctly. The image of Kermit the Frog relaxing in bed represents the person's desire to procrastinate and avoid the task. I couldn't have said it any better, honestly. Can you explain this meme? My handwriting in exams. First 2 pages. That got a chuckle out of me. Middle page. Last 2 pages. This is actually very, very funny. This meme highlights the deterioration of a person's handwriting during an exam. The first 2 pages show neat and legible writing. The middle page shows slightly messier handwriting, and the last 2 pages show almost illegible writing. What is funny about this image? You see the world as you are. It is a cartoon of a rhinoceros painting, which is unexpected and silly. The rhino is painting a picture of itself, which adds an extra layer of humor. So I think it probably got this wrong. It's not really painting a picture of itself, is it? It's a joke about how we all have our own unique perspectives and can be a little self-centered at times. Well, yeah, this kind of makes sense. All right, you tell me what you think about this, and if you think it accurately got it. Science and knowledge. Which of these oceans does the prime meridian intersect? The Atlantic Ocean, Southern Ocean, Arctic Ocean. I'm wondering if it could answer this without the image. I don't know if it needs the image to answer this correctly. There are some signs here as well, and it goes on to calculate that. Here's another example. Which of these states is farthest north? In this case, Delaware. Which of the organisms is the producer in this food web? Here's some more science examples. What do you think about GPT-4V's application so far? Or is it giving you any ideas of how to use it in the future? Do let me know in the comment section. Now here's common sense. What is person 3 doing? For a human, it's so simple. What is person 1 and person 2 doing? Person 1 and person 2 are walking down the aisle at a wedding ceremony. Suppose you're a detective. What can you infer from the visual clues in the image? Let's see what GPT-4 says. The room belongs to someone who's likely a young adult or teenager. Evidenced by casual clothing, the person is likely a student or someone who works from home. evidenced by the desk and computer. The person is likely fashion conscious, as evidenced by the multiple jacket and shoes. I'm not too sure if this person is fashion conscious. The room is likely located in a colder climate, as evidenced by the jacket. Yep. The person is likely not very tidy, as evidenced by the cluttered desk and clothes hanging on the door. The room is likely located in an older or more rustic building, as evidenced by the exposed pipe and worn-looking walls. Next, we'll look at how it's able to understand scene text, tables, charts, and document reasoning. Traditionally, some of the way of reading text or charts has been to use OCR, which is optical character recognition. But GPT-4 seems to be doing very good at this, bypassing entire machine learning pipelines requiring OCR. What are all the scene text in this image? It gives you the correct answer here. There's also visual math, where you can quickly write down a math problem and then ask it to answer it for you. You can also understand flowcharts. Let's quickly go through some of this here. Chart understanding, it translates that for you, what's happening in there. This one is a very interesting and specific one. Can you translate the flowchart to a Python code? You get a number variable, you get a second number variable, and then you check if number 1 is greater than number 2. If that's true, display number 1. If it's false, display number 2, and then you end the function. So easy function here. Here are more charts. And this is understanding tables. How many families are earning more than 13,000 and owns more than 2 cars? So it seems it got this right as well. This is pretty impressive. Considering where GPT started from a few years ago to GPT-2, and now GPT-4 is just mind-blowing and fascinating. I actually covered the history of OpenAI and its GPT series, as well as other LLMs and visual models. I think you'll love that. I'll leave the link in the description below and you can check that out. It's just exciting to see how far LLMs have come. You can give it document understanding and it can describe the image for you. This is a floor plan. There's a terrace, a dining area. The floor plan is black and white. So it gives you some insight into what you're seeing. This can help people who have issues seeing. And that's how OpenAI deployed their vision model initially with the company Be My Eyes, where you can help the visually impaired or blind people see. So more examples here, you can give it a logo, a banner, a screenshot, and it'll answer these questions for you. It seems it did get something wrong here. This is a paper. Describe the paper in details. Considering you got all of this correct and just a few wrong, this is already great. But that's why you should always double check your work from ChatGPT or the GPT-4 output. Now we get to multilingual multimodal understanding. So this involves different languages. Let's look at some examples. We'll move on to temporal and video understanding. This one should be more interesting. We'll look at things like multi-image sequencing, showing how GPT-4 can accurately comprehend and analyze sequences of video frames. There's also the video understanding part, temporal ordering, which is a crucial part of understanding what's happening in the video. There's also temporal anticipation, showing how GPT-4V is able to anticipate the future. So let's go through some of the examples here. So given a video, which is obviously a sequence of frames, explain the images and actions the person is taking. GPT-4V responds, a person in a motion capture suit in a studio with multiple cameras and sensors. The person is performing a push-up exercise, which looks like it's happening here. Here are some more examples. Analyze the images and decide the correct order in which they should be displayed. The correct order should be E, mixing the rice, C, placing the rice on the seaweed, B, adding the fillings, A, cutting the roll, and D, finish sushi roll on a plate. So it seems they got this right as well. Predict what will happen next based on the images. It says based on the image, it appears the player in the white jersey is taking a penalty. Similarly, we have an example here for sushi. So here you can see there's temporal sequencing. It understands visual elements in a video or a sequence of video frames. This is another task for visual models. In which frame does the player kick the ball? Did the goalkeeper block the ball? So the player kicked the ball in frame C, and the ball is in the net, and the goalkeeper is on the ground. And we can see that in frame F. Here are some more examples using pointing. Describe and summarize what the circled person doing. Which one of the 5 designs makes the best comparison? This is to that, as this is to... Answer is C, so it gets that correct. Here are some more examples of reasoning tasks. Now, the next very interesting thing is emotional quotient test, reading emotion from facial expressions. So this is quite interesting that Microsoft tested this. In the past, Microsoft has scraped projects around emotional prediction. So it's quite interesting to see they're testing it here, but also to see how far GPT-4V can go. Because who are we to say someone can have a resting face or a naturally happy face, but that might not really translate what they're feeling inside. So that's quite interesting because they may be subjective and intrinsic to the person. After seeing the below image, how people might emotionally feel and react. People might feel happy. It looks like it analyzes the image, and then there's a prediction of what the emotion around it should be like after experiencing such a picture. For this one, it says people might feel angry, frustrated, and upset. They might react by feeling a sense of injustice. So there seems to be more investigations around this, understanding humans' emotional response to certain images. This can be used, for example, by brands in terms of images they send out on social media or for banners or ads. Describe the image in a humorous way. Let's see how this responds. It looks like the sun is trying to hide behind the horizon, but it's not doing a very good job. It's like it's playing peekaboo with us. And the seaweed is just chilling there, like, hey, don't mind us, we're just hanging out. That's quite funny. The rocks are probably feeling left out. They're like, hey, what about us? We're part of this beach too. Very, very interesting take on this. I like this. And that was quite funny, honestly. Describe the image to make people feel uneasy. The image is of a dark, shadowy staircase. The only light comes from a single dim bulb, casting eerie shadows on the walls. The railing is old and rusted, with peeling paint and jagged edges. The air is thick and musty, and there's a feeling of unease, as if someone is lurking in the shadows. The silence is deafening. There are some more examples here, but we don't have the time to go through everything. Grocery checkout example. For below image, find what products are presented in the basket. Try to be accurate. I get some of it correct, like pink tulips, sliced ham. It says there's Greek yogurt and raspberries in there. Now, if you're provided with images of what each of the items in the grocery store should look like, it selects all 5 products correctly. Smoked ham, apple, pink tulips, crab dip, and strawberries. This can easily be used by grocery stores for quick checkouts. Enter the grocery store, pick up the item you're looking for, take a picture of it in the basket, and automatically get charged. Obviously, GPT-4V will need to get to a very, very accurate level before this can be implemented at scale. Also in auto insurance industry, imagine that you're an expert in evaluating the car damage from a car accident. Please evaluate the damage seen in the image below. It gives you a rundown of what it's seen. The auto insurance companies can also use this to facilitate their work. There's also a customized captioner example. So here you said, please describe the image with as many details as possible using my family members' names. And you get a very good output here. You see another example here, individual images, and then the result. It identifies the faces correctly. Exploring how to bridge the gap between multimodal understanding on static inputs and physical interactions with dynamic environments. How to use GPT-4V to understand operating machines. For example, understanding the menu or navigation purposes. Let's look at some examples here. First, read the operating menu below for coffee machine buttons. And here's the menu. Now let's look at the operating panel of the coffee machine in the image below. Which button should I use for 8 ounces coffee? GPT-4V mostly gets it right, but it says while the top button is for 6 ounces of coffee. So interesting use case. Here's another example. Imagine that you're a home robot and is asked to go to the kitchen to fetch something from the fridge. The image below shows your current position. Please plan your next action. My next action would be turn right and move towards the hallway. As I can see, the kitchen is likely located in that direction, which is smart. I would then continue to navigate through the hallway until I reach the kitchen and locate the fridge. So it's identified that this is not a kitchen and there's no fridge in here. The next thing is to go through the hallway where you'll possibly find the kitchen. So once the robot moves, now this is the hallway. It now says, from the current position, I can see the kitchen on the right side. My next action would be to turn right and move forward towards the kitchen. Now, my next action would be to move forward and slightly to the left to align myself with the fridge door. Then I would use my robotic arm to open the fridge door and retrieve the requested item. This incredible work. There's also GUI navigation, evaluating a screenshot or a website. Here are some examples. So this is quite interesting, asking GPT-4V how it'll interact with the computer. Imagine that you're a robot operating a computer, like how humans operate the computer. You can move the mouse, click an icon with the mouse, or type some text with the keyboard. You're asked to find a detailed recipe of mapo tofu. Below is what you see on the computer screen. Predict your next move. If the action involves moving the mouse, describe the location as detailed as possible. So here it says I would move the mouse to the Google Chrome icon located on the left side of the screen, approximately a third on the way down from the top. I would then click on the icon to open the web browser. Next, I would move the mouse to the search bar located in the center of the screen, approximately half of the way down from the top. I would then click on the search bar and type in mapo tofu recipe using the keyboard. After typing in the search query, I would press the enter key on the keyboard to initiate the search. So in terms of navigating via text, GPT-4V is doing incredible work. It knows how to navigate the entire website. There's only one error here, 4.69 stars out of 5, but it's 4.89. I mean, considering all the steps it had to take to get here, this is still mind-blowing, if you ask me. So here's another example of you're asked to find what's in the news today. Another interesting use case for GPT-4V, in this case, we're transcribing the video content given the frames below. So this is an entire video. And what's happening is each frame is screenshotted and passed on to GPT-4V to explain what's happening. So imagine you have an automated system, which is GPT-4V, just sifting through a lot of TikToks or YouTube shorts, transcribing them, analyzing them. That's a possibility we'll soon see in the coming months, where everything is automated and the algorithms behind TikTok, YouTube would be enhanced by some of these systems for possible harmful content, malicious content, interesting content, and putting them into different categories. So we won't read all of this, but you can see it does a transcription pretty well. Here's some more examples. The paper also explores future research directions that may further amplify GPT-4V's capabilities. Please determine whether each person in the image wears a helmet or not, and summarize how many people are wearing helmets. Initially, we saw that this might have given a problem, but now it thinks through the idea, there's an action attached to it, and there's an observation. So it goes through a bunch of steps. You can call them chains. It chains all these steps together and comes up with an answer. Out of 8 people, 5 are wearing helmets and 3 are not. So this is a wrap of today's video. Thanks a lot for being here with me. It was very extensive. Let me know what you think about GPT-4V and all of these applications, all of these tests, and the future ways of using them for downstream tasks. You can see how big corporations, smaller startups, and personal use will expand over the years. There are other brilliant and absolutely informative videos we've covered on this channel. From AI negotiating with countries to AI robots in conflict, it's all here. Thanks for watching, and until the next video, it's goodbye.